Question number 4. Using an illustration in each case, differentiate between mutually exclusive event and dependent event as used in probability. Mutually exclusive and dependent event as used in probability. Let's start with the mutually exclusive event. You can say that two events are mutually exclusive. Two events are mutually exclusive if they cannot occur or occur at the same time. As they are mutually exclusive, when this happens, that it prevents the happening of the other events. E.g., a person cannot run forward and backward at the same time. Or the common example we shall say when you are tossing a coin, the happening of the head prevents the happening of the tail. You cannot say that the tail and the head, they are happening at the same time. Now those two, the head and the tail, they are mutually exclusive events. Then we talk of dependent events. Dependent events is the probability of occurrence, probability of occurrence of one event influences the probability. One event influences the probability of another event, which causes the other event to happen. Now we can say that this particular probability is depending on the happenings of the previous event. That is when we talk of dependent event. Then we look at part B. So an employee's probability of waking up on time is to that if she works on time, there is the probability of 9/10 that she will catch the train and be on time for work. If she misses the train, there is the probability of 1/4 that she will be on time for work. Now, in this case, we are having two events: waking up early and the other one oversleeping. Now this, let's come up with now we are told that Roman 1, draw a tree diagram to represent the above probability. Then Roman 2, the probability that employee catches what? The train. Then lastly, the probability that employee is late for work. Then the probability that the employee oversleeps and she's on time for work. Now, let's come up with the probability. This one, waking up on time, just on time. This one, over what? Sleeping. We are told that the probability of waking up on time is what? 2 over 3. Now here is 2 over 3. Meaning oversleeping is a part. Then we are told that if she wakes up on time, there's a probability 9 over 10 that she will catch the train. Now here is a probability that she will catch, let me use catch train. Then here misses the train. Then here also, if she oversleeps, most likely she will not walk to work. She might catch the train and be on time and misses, which results to being what? Late. Now we are told that 9 over 10 she will catch the train. Now this is 9 over 10. She will catch the train. Meaning the probability of missing the train, 1 minus 9 over 10, we have 1 over 10. Then here, if she misses the train, there's a probability that a quarter she will be on time for work. If she misses the train, there is the probability of a quarter that she will be on time for work. Now here, half a quarter, then 3/4 she will what? She will miss. Now we are told the probability the employee catches the train. Now in that case, the probability of catching the train, we have already been told that she wakes up and she'll have what? 9. That she have a 9 over 10. We are multiplying by 2 over 3, which is here 1, here 3, here 1, here 5, which is 3 over 5. The probability that the employee is late for work. Probability of employee is late for work. We have that is 3, 2 over 3 multiplied by 1 over 10. Then oversleeps, 1 over 3 multiplied by 3 over 4, which is here 1 is 5, which is 1 over 15. We are having that's a quarter. You'll see my case here should be 60. That is 4 plus that is 12. Have 16 over 60 for there. 4 for here, 15, which is 4 over 15. The probability employee oversleeps and she's on time for work. Oversleeps and she's on time for work. That is now 1 over 3 multiplied by 1 over 4, which is 1 over what? 12. Probability she oversleeps, but she will be on time for work. Then lastly, the sales revenue of 20 thermos flasks and 12 cups is 39,600. The sales revenue for a thermos flask and 17 cups is 19,500. The sales price of each of the items had a markup of 20 required. Roman 1. The selling price of the items using the matrix. Now let's try to determine this particular matrix. First of all, we have to arrange it in a simultaneous form. We can say that let or variable set let, that is flask, thermos flask be my x, and cups, they are going to be represented by y. Now we are told that the sales revenue of 20 thermos, now it will be 20x plus 12 cups, 12y is equal to 39,600. Then the sales revenue of a thermos 8x plus 17 cups is equivalent to 19,500. And the selling price, remember with the header markup, we can determine the markup after we have gotten the value or the market price after we have gotten the value of each flask and thermos. Now at this point you can arrange in matrix form. Is going to be 20, that is 12, 8, 17, xy is equivalent to 39,600 and 19,500. At this point you can determine what you call determinant. Determinant, how do we get determinant? This is the column of interest. I'm going to have 20 multiplied by 17. We minus 12 multiplied by 8. 20 multiplied by 17, let me just confirm, but should be 350. 20 multiplied by 17, yes, 340. We are minusing 12 multiplied by 8. We have that is 96. 340 minus 96, you should be getting 244. 244 as our determinant. The next thing, I'm going to determine what we call the inverse of a matrix. Inverse of this particular matrix. How do we write the inverse of a matrix? This meaning the whatever I underlined, we are going to interchange the positions. We are going to have 17. This one will be negative 12. Now to change the signs, negative 8, and this one will be 20. This is then the inverse of this one is going to be 1 over 244. That becomes our inverse of a matrix. If I multiply this particular inverse on this particular side, we'll get what we call we are going to get that is 0, 1, 0, 1, sorry, 1, 0, what we call identity matrix. There's no need of going that route. Let me just multiply this particular inverse directly with this particular matrix by giving x, y is equal to, now I take this one, I multiply this particular side, that is 39,600, then 19,500. Correct. Now here is going to be x, y is equal to 1 over 244 into, now it's going to be 17 multiplied by 39,600 minus 12 multiplied by 19,500. Here we have is going to be negative 8. I multiply by 39,600. We add 20 multiplied by 19,500. The xy is equal to 1 over 244 into and let's try to calculate that. That is 17. We are multiplying by 39,600. We have 673,200 minus 12 multiplied by 19,500. I have 234,000. 234,000. Negative 8. I multiply by 39,600. We have here negative 316,800. We have 20. We are multiplying by 19,500. we have 39, that is 390, no, sorry, 390,000. X, Y, which is 1 over 44, 2, sorry. Now we have 673,200 minus 234,000. We have 439,200. Then we have negative 316,800. Just a minute. Delete that one. Yes. Plus 39. That is 73,200. 73,200. Now at that point we can just divide to get a value of X and Y. Now the value of X, we're just going to take the answer, this one, divide by 244. We realize that the value of Y, it is 300. And then when we divide, that is 43,200, we are dividing by 244, we get 1,800. Meaning, the price of one thermos flask, it was 1,800, the selling price, correct? And then that of a cup were 300 shillings. Now we are told that the cost price per item, remember these particular prices had a markup of 20. Therefore, we can just say that if 120% it was, that is for X, that's thermos, it was 100. What about 100%? You want to determine the cost price. If 100 multiplied by 1800, we divide by 120. Answer multiplied by this 100 divided by 120. Meaning the cost price of one thermos flask was 1,500 Kenya shillings. And then we had what about a cup? We can just do the same. That is for wine. It's going to be, if 120%, it was 300. What about 100%? What will it be? Now it will be 100. We are multiplying by 300 over 120. Meaning one cup, it was Kenya shillings 250. That is the cost price of those items. That's the question number 4, both part A, B, C, with alongside with those particular Romans. We are meant to do it with that algebra. Remember question number 4C, they were specifically use a matrix algebra, not using simultaneous equations to solve it. But you can use simultaneous to verify whatever you got is correct. You can just use your, we say the eliminations or substitutions to determine what ought to be the correct answer. Then we had there the probability, and the question number part 8 was asking the difference between mutually exclusive and dependent variables. Thank you.